So this is just a little example. Make sure that you can get in the calculator and all that kind of stuff. What did you guys get for this? 0.05.
3.9.
3.9. Okay. So that didn't have anything to do with the questions. I just wanted to show you an example of how to put it in the calculator just so you have it. So this one, n is always 44 for this problem. Problem number 1 has 44 people. I can't change that by asking a different question about them. But in this case, what does change? How many successes do I want for part A? 7. P is always 0.152. I can't change the percentage of San Diegans who smoke by asking a different question. That would be freaky, right? I ask a different question, so I'm like, I'm done. I'm just gonna have a French accent. I'm sorry. Jeez. All right. And then so P is always 0.152 for this problem. And so in Q is always 0.848. Now how many successes do I want? 7. So how many failures do I have to have? 37. So these two always have to make 44 total. Because you are one or the other. And you should get that. Okay, I like it. Are we alright with that? None of them smoke. This is where weirdness happened a bit. So no successes. None of these guys. Everybody's one of these guys. And I love that some of you guys remember that you just have to put that much in. And what you get is a hot mess. You get, oh shit, especially if you do that job. You get that weird shit, right? And anytime you have the little e dude, please don't just write 7. That's a little bigger than 1. That's a 700% chance. I don't even know what that means. It's like they still don't smoke, but people stop smoking near them. They like to smoke black holes. So that means E means times 10 to the. And all you really got to remember about scientific notation is that power tells you how many places in which direction to move. So back 4. So 1, 3 zeros. Right? If that was negative 11, you would have went 1, and there would have been 10 zeros. So there's always 1 less 0 in front than what it says when you move it backwards. So this just becomes, rounding it to 4 places makes it go to 0.0007. Now I haven't made it a percentage yet. That is the number. That's just another way to represent the number. That's the number. What is it as a percentage if you want that? 0.07%. Which our brain kind of balks at, but it's very, very unlikely. That's all it means. What's the chances I'll die in the surgery? 0.07%. I'm like, that sounds good. That's probably better than just my day-to-day chance of dying. That's pretty good, doctor. All right. And my little brother's not your doctor. It's all good. And then this is the same. I mean, you got to be careful about this, but most of the time when I say at least 1, anytime I ask a probability question, you could do the opposite probability subtracted from 1. It's always an option because it's got to be true. That's how they work. I'm only going to do it when there's less work. If I want to answer this directly, what does that mean? I have to set up that formula for 1, plus set up the formula for 2, plus set up for 3, all the way to 44. That would come out to the right answer. Does anyone want to do that? All right, I'm trying to find my smart asses. Yeah. I'd much rather do 1 minus the opposite because there's only one way. I've already done it. There's the opposite situation, right? Good Lord. What's in that? 1 minus 0.0007. Right? It's like the cheap James Bond or 007. So 1 minus 0.0007 is, make it 9, make it 9, make it 9, make it 10. So most humans would say it's basically going to happen. If you get 44 randomly selected San Diegans, at least one of them is going to smoke. Remarkably small chance that that won't be true. So if I had a party and 44 people were coming, random people, I'm going to put out an ashtray or put a sign up saying, you better be on fire if you're smoking, or whatever, depending on your opinion about smoking. Okay. By the way, this was about tobacco, not something else. Now this, and again, these are the best formulas we've seen yet. You gotta love these formulas. The mean, what's n?
44.
44, what's b?
0.152.
What do you get when you multiply those?
6.68.
Say again?
6.688.
6.688. And then the square root. Some of you guys might realize, now here's how I would do this in the calculator real quick. This isn't even that amazing, but you got to do 44 times 0.152. Then I do the square root of that times q. Ooh, because that's already n times p, and this just needs times q. So I get 2.381. Yeah. Now, I've kind of brought this up at least once, but now we're going to make it official. Right now, we consider unusual to start 2 standard deviations out. So if I saw somebody whose height was 2 standard deviations below the average height, that would be an unusual occurrence, right? I would kind of do a double take. Whoa, I don't see that every day. Or the other way around. Whoa, I don't see that every day, right? Because remember that empirical, that percentage thing I talked about. Within 2, there's 95% of the data for normal distribution, which means only 5% is outside of it. Even for a not normal distribution, there's 75% of the data in there, so there's still a decently low amount out there. So we consider right now, we're considering 2 steps away to be where unusual starts. Yes, no, maybe? Sure, whatever you say, John. Later in this class, we will define unusual more specifically. If I am in a nuclear power plant and my needle starts to go towards the yellow, am I going to wait until it's 2 steps above normal? No. I'm going to consider unusual to start maybe half a step up. That sucker starts to go, I'm like, what the shit? You don't want to attract Godzilla. All right. Don't want Bryan Cranston to lose his wife. You see that? All right. No response? All right. So this is going to feel like before, but how many steps am I taking now? 2 up and 2 down. So the mean is 6.688. If I go 2 steps up, so I want 6.688 plus 2 of these. Where do I end up, sorry? 11.45. And then if you go 2 steps down, so I want 6.688 minus 2 of these. And some of you guys might realize this is basically the work you needed to do on that second part with the group of people drinking beer on the test. Some of you guys had Finnish people, some of you guys had Swedes, I can't remember. Germans, I think was on there. I can't remember who I put on there. And those are, by the way, correct averages for beer consumption across the world. I'm sorry, what's this one? 1.926. So would it be unusual to get 15? Because that's way more than I expect. This is the maximum expected, maximum usual. And this is the minimum usual. So if I got 15 out of 44 roundly selected San Diegans who smoke, I've got to stop and say to myself, where am I? Am I in a different area where more people smoke? This is related to the expected chances of cancer occurring in an area, and then more cancer, and then an unusual number of cases. This is how they define unusual. And then you go and you check. Does this mean it's impossible? Obviously not. But this does mean that it's unusual, and you might want to do some more sophisticated tests on that whatever area you're in. You guys kind of with me? Maybe it's an Aaron Brockovich kind of thing for the cancer. Again, most of my references are old, so I'm sorry. It's just too bad. All right. What do you say we have a really early day? Is that all right with you guys? Is anybody upset that I'm not giving you your money's worth? I actually had somebody say that once. I don't let you out early all the time, but I want to be nice to us today. Give us Is that all right? Being nice to me too, but let's do it. Okay.